moving heat around, lateral direction of heat flow. In normal condition, heat flows from a body of high temperature to a body of low temperature, that is, from a hot object to a cold object. However, an air conditioner acts as a heat pump that transfers heat reverse its lateral direction of flow. In fact, an air conditioner transfers heat from the cold region to the hot region by using the pump. How can it be done? Let's first look at the essential components inside an air conditioner. The first component is the refrigerant, 雪種. Refrigerant is the fluid inside the tube which helps to remove heat from inside, that is, remove heat from the room during evaporation process. That is, the refrigerants change from liquid state to vapor state. Also, the refrigerants will help to remove heat to outside, that is, remove heat to the surrounding during condensation process. During condensation, the refrigerants change from vapor state to liquid state. The second essential component is the compressor. The compressor increases both the pressure and the temperature of the refrigerants. The third essential component is the condensing coil. Inside the condensing coil, the refrigerants condenses, change from vapor state to liquid state by releasing heat. The fourth essential component is the expansion valve. The expansion valve decreases both the pressure and the temperature of the refrigerants. The fifth essential component is the evaporator coil. Inside the evaporator coil, the refrigerants evaporate, change from liquid state to vapor state by absorbing heat. The last essential component are two fans. The fans inside the air conditioners helps to increase the rate of heat exchange in both the compressor coil and the evaporator coil. The working principles of the domestic air conditioner are as follows. The first step, when warm air of the refrigerants enters the compressor, both the pressure and temperature of the vapor will increase, and the vapors become hot. Next, when the hot vapor passes the condensing coil, it releases heat to the hot air outside. And condenses back into liquid. Next, when the warm liquid refrigerant enters the expansion valve, both the pressure and temperature of the vapor will decrease, and the liquid becomes cold. Next, when the cold liquid passes the evaporator coil, it absorbs energy from the cold air inside the room and evaporates to vapor again. As a result, heat is removed from inside to outside. Notice that for air conditioner, heat is flowed from a cold region to a hot region, which is against the lateral flow of heat. Note that the refrigerants can be made of carbon dioxide or ammonia. Second, water drippings occurs in evaporator coils. The evaporator coil is cold, and the water vapor in the air will condense on the coil and dips back. Also, air conditioner is against the lateral heat flow because it removes heat from a cold region, that is the room, to the hot region, that is the surrounding. For a central air conditioning system, 中央冷氣系統, the heat generated will be used before exhaust into the atmosphere. This can be done by using chiller to collect the heat for preheating water in water pipes. This provides hot waters in buildings such as hospitals and shopping malls. Cooling capacity. What is cooling capacity? Cooling capacity is the rate at which heat is removed from a room. We have cooling capacity equal to Q over T, where Q is the heat removed, T is the time taken. And the unit of cooling capacity may be joule per second or watt. What is coefficient of performance for an air conditioner? COP. COP is the ratio cooling capacity to input electrical power. The COP tells us how efficient an air conditioner is. The higher the COP, the greater the end-use energy efficiency of an air conditioner. Notice that COP has low unit because cooling capacity and input electrical power have the same unit in watt. The input electrical energy is used up by the compressor, which turns to heat eventually. Therefore, the total amount of heat removed to outside per second is the sum of the input electrical power and the cooling capacity. Example 1. An air conditioner removes 20 megajoules of heat from a room in 1 hour. Part A. Find the cooling capacity of the air conditioner. The cooling capacity is equal to 20 megajoules over 1 times 3600 seconds, which is equal to 5.56 kilowatt. Part B. The total amount of heat removed to outside equal to the sum of the cooling capacity and the weighted power, which is equal to 5.56 kilowatt plus 2.5 kilowatt, which is equal to 8.06 kilowatt. Example 2. The air inside a room has a mass of 150 kg and the specific heat capacity of air is 1000 Joule per kg per degree Celsius. If the cooling capacity of the air conditioner is 3 kW, find the time taken for the room temperature to be lowered by 5 degrees Celsius. The heat energy removed to outside is equal to mc delta T equal to 150 times 1000 times 5, which is equal to 7.5 times 10 to the power 5 joules. Therefore, the time taken is T equal to 7.5 times 10 to the power 5 over the cooling capacity, which is 3000 watts. Therefore, the time is 250 seconds. Now, let's look at the central air conditioning system, 中央冷氣系統. For a domestic air conditioner, air is used to exchange heat with the refrigerants. However, for a central air conditioning system, we use water to exchange heat with the refrigerants because of its high specific heat capacity. The essential components of central air conditioner system are: first, we have a chiller. In the chiller, the water is cooled by the evaporator coil. The cold water flows to the air handling unit, AHU. The fan will blow hot air around the chilled water, and this hot air is cooled and becomes cold air, and this cold air will be distributed to various parts of the building through the air duct. The second component is the cooling tower. In the cooling tower, water is being heated by the hot condensing coil. In hotels, hospitals, or shopping mall, the cooling tower supplies hot water for use. In washing, the Energy Efficiency Labeling System (EELS) for all the electrical appliances. There are 5 grades in EELS, with grade 1 is the most efficient and grade 5 is the lowest. That is, the lower the grade, the higher the efficiency. The higher the grade, the lowest the efficiency. The products of different categories are graded by calculating their energy efficiency index, i.e., the energy efficiency index is found by the ratio of the actual energy consumption by the product over the average energy consumption of the product in the same category. If the index is smaller than 100%, the product is more energy efficient than the average in that category, so it has a lower grade. If the index is larger than 100%, then the product is less energy efficient than the average in that category, so it has a high grade. Example 3. The following labels are marked on 2 air conditioners P and Q. If electricity cost is $0.85 per kilowatt hour, how many years it takes to pay back the difference in price between the 2 air conditioners with the savings on electricity? For P, the electricity cost per year is equal to $0.85 times 1500, which is equal to $1,275. Similarly, for Q, the cost per year is equal to $0.85 times 1200, which is equal to $1,020. The difference for the cost per year is equal to 1275 minus 1020, which is equal to $255. The difference in the price is equal to 4500 minus 4000, which is equal to $5,000. Therefore, the time need to compensate is T equal to 500 over 255 equal to 1.96 years.